Welcome to Sky from Scratch episode 4. In this episode, I will walk you through every essential component I chose for my FPV drone build and why. From motors and to ESCs to flight controllers and batteries, I will explain how each part works and how they come together to make your drone fly. So whether you are building your first quadcopter or just want to understand how these machines come alive, this video is for you. There will be no sponsorship and no fluff. It will be just an honest guide to real world parts and smart choices for builders like you. The following topics are covered in this video. Which drone frame to choose and why mine worked so well. Understanding motors, ESCs, propellers and batteries. What a flight controller does and why I chose the Pixhawk 4. And how I sourced my parts online without any promotion. And the thinking behind the build. This is more than just buying parts, it is about building understanding. So let's begin. Have I got that mad scientist look yet? Okay, so let's begin. So why did I choose the more expensive Pixhawk 4 over cheaper flight controllers out there? Pixhawk 4 is the smartest brain for serious builders. Pixhawk 4 is more than just a flight controller. It is a powerful, flexible and incredibly stable brain that can handle everything from a beginner quad to a pro-grade autonomous aircraft. But the most important thing is its hardware. Its CPU and sensors have industrial-grade reliability. Also, there are redundant sensors, which means extra sensors which will save your day and your biggest investment, the drone, if a sensor or an inertial measurement unit fails mid-flight. The Pixhawk 4 also has a dedicated system to reset the flight controller if the main CPU freezes during flight, so your drone doesn't crash or fly away, which will make you lose your investment or at worst have legal liabilities. This is called the watchdog. The Pixhawk 4 also has two power inputs, so if one power supply fails, your drone still flies home. The Pixhawk 4 supports autonomous missions, GPS-based navigation, fail-safes, loiter, smart return to landing, auto takeoff, landing, and it is also compatible with Mission Planner and Q Ground Control, the two most popular ground control stations. The Pixhawk 4 has a very powerful CPU which seamlessly handles the telemetry, GPS, auxiliary units as well as complex navigation systems like the LiDAR, rangefinder, thermal cameras and optical flow sensors. While paired with a quality GPS like the M10, the Pixhawk 4 can maintain a rock-solid position hold even in the wind. And its onboard sensors work together to keep your flight balanced. Best of all, you can tune it endlessly. PID, filters, failsafe logic, flight modes, but one of my favorite things about Pixhawk 4 it is that it is built for safety. From pre-arm checks to battery failsafes, return to home, flight back black box logs, it watches over your drone like a co-pilot. The PM07 power module for the Pixhawk 4. This is the heart of your drone, so don't skimp on it. For power distribution, I am using the PM07 board designed for Pixhawk 4. It comes with the Pixhawk 4 or you can buy it separately. It is reliable, it provides clean voltage sensing, current monitoring and built-in safety fuses. It keeps the flight controller protected and the wiring neat. It also supplies dual independent power to the Pixhawk 4 so as to keep your drone flying even if one power supply unit has failed. The M10 GPS module. This GPS is the eye of your drone. For navigation, I chose the M10 GPS. It is lightning fast to lock on even under cloudy skies and it stays rock solid during the flight. The M10 has better sensitivity, EMF rejection and more satellite support than the older M8 series, which gives my drone tighter position hold and smoother autonomous missions. Earlier I started with the Holybro M10 GPS, but now I have moved on to the Foxeer M10 GPS due to reliability issues I faced with this particular make. GPS stand. This GPS stand might look simple and optional, but it is essential. It lifts the GPS above the electromagnetic noise from the power system and the ESC, which improves accuracy and quick fixing and reduces GPS glitches. It also folds down for transport. It is the telescope that a ship's captain holds. The MT-2213 motors. These are the muscles of your drone. My drone uses MT-2213 brushless motors. These are cheap, these are balanced, efficient and reliable. They provide a perfect blend of lift and endurance for my S500 frame when tuned correctly. Each has almost 850 grams of thrust at 3S battery, which is better than an industry standard, so I did not have to spend so much on a 4S battery. The BL Heli one shot 30 ampere ESC. This is the nervous system of your drone. Each motor is driven by a 30 ampere BL Heli one shot ESC. These are fast, responsive and easy to calibrate. The one-shot protocol reduces signal latency, giving smoother throttle response and better stability in flight than other protocols. While 18 ampere ESC would have been sufficient for my build, I over-engineered with a 30 ampere ESC in order to increase stability, reliability and reduce heating. The Emax 1045 propellers, which are made of nylon and glass fiber. For propellers, I went with the Emax 1045 propellers made from nylon reinforced with glass fiber. They are light yet stiff, so they don't flex under load, which means less vibration and more efficiency. These propellers handle my 3S battery perfectly and help with smoother hovering. I tried carbon fiber propellers, though they had the best performance, they were outrageously expensive. I tried ABS propellers as well, but one broke during mid-flight and crashed my drone. But these Emax 1045 propellers match the motors very well and show minimal wear and tear even after hours of flight under their leading edge. S500 fuselage or the frame. The S500 frame is the skeleton of your drone. It's carbon fiber reinforced, so it is strong, inflexible, reliable, light, modular and very easy to work on. I love how its arms spread out evenly, giving excellent propeller clearance, and the vibration damping on the center plate keeps the flight footage stable. You have tons of space for accessories, gimbals, a large battery, has up to 2.5 kg load capacity and also supports up to 12-inch propellers. This is the fuel of your drone. My power source is a Bonka 5200 mAh 35C 3S LiPo with 180 amperes of peak continuous current, plenty of juice for a stable long flights. It is a great balance between capacity and weight, giving me around 18 minutes of hover time with consistent voltage input. For telemetry, I built my own HC12 wireless module. It is compact, cost effective and works beautifully with Mission Planner. It lets me view live data, altitude, GPS battery from my laptop without spending extra on brand name systems. In one of the following videos, I teach you how to build such a telemetry for just Rs 500. Hawkeye Thumb 4K camera. For visuals, I use the Hawkeye Thumb 4K. A small, lightweight and surprisingly capable. It captures crisp aerial footage without the bulk of a gimbal and with gyroflow stabilization. It feels like cinematic flight but without the extra weight. The Zemco Ruibet 1.6 watt video transmitter with pagoda antenna. For video transmission, I picked the Zemco Ruibet or a rabbit. Say 1.6 watt video transmitter paired with a pagoda antenna. It is quite cheap at just Rs 3000. I bought it from ebay.com. It pushes strong clean signal even through trees in the distance, and that omnidirectional pagoda antenna design keeps the video feed stable no matter at what angle the drone is flying. The generic 5.8 GHz video receiver. On the ground, I use a simple 5.8 GHz video receiver. Nothing fancy, it just works. It's reliable, easy to pair, and gives me consistent real-time visuals for FPV monitoring with my laptop or Android phone. The FlySky FSI6X with FSIA10B receiver. For control, I use the FlySky FSI6X radio paired with the FSIA10B receiver. It's budget friendly, reliable and has 10 channels for all my modes. Camera triggers and failsafes. Simple interface, strong link, never let me down even at 1 km range. Navigation lights. I added navigation lights. Red at the left, green at the right and white strobe lights and a bright blue light at the back. They make orientation crystal clear during flight, especially at dusk, and add that real aircraft look to that build. And this thing is very essential. It is a vibration isolator. It keeps the vibration from the propellers and the drone frame away from your flight controller, so the flight controller does not get confused about its orientation, its gyroscope precision, and also the inertial measurements, so that your flight remains completely stable. No, this is not optional, this is very essential. And then there are ancillary tools and essentials. Of course, every builder needs these essentials. Loctite for securing screws. Most YouTubers and tutorialists forget this, but Loctite or any other thread securing glue is not optional in an aircraft. Look up in the internet how many crashes history has seen of full-sized aircrafts when a nut or a cotter pin was not secured properly. You need a precision screwdriver set. In addition, a few male and female XT60 connectors from AMAS for clean power links, and soft silicone wires for flexible vibration resistant wiring. These small things make the build durable and professional. And also you need a 60-watt soldering iron, a very good quality with adjustable temperature. Every part here has a purpose, none of it is random. Each decision from the frame to the wires adds up to a drone that is not only functional but personal. That is the beauty of building from scratch. Drop your questions and suggestions in the comment. I reply to every fellow builder. If you found this video helpful, give it a like and hit that subscribe button. It really helps to make the channel take flight. My mission is all about making zero cost, high quality drone and aircraft building knowledge available to everyone. Thanks for flying with me. This is Sky from Scratch. See you in the next flight.